Hare Krishna. This is day 5 of October LeetCode challenge. So majority element 2. So basically we will be given one integer array of size n and we need to find the elements who appeared more than n by 3 times. If we take this example 3, 2, 3. So let me show here 3, 2, 3, 3, 2, 3 where n equals to 3, 3 divided by 3 which returns me 1. So we need to return the elements who appeared more than once. As we can see, only 3 is the one which appeared more than once. So this is all about the problem statement. So now let's see how we can solve this problem. So there are multiple ways to solve this problem. So one is using two loops. Basically, let's assume we have input something like 1, 1, 1, 1, 3, 2, 2. Okay. So here n by 3, that is nothing but 7 by 3, which is 2. So the only output is going to be this, right? Because 1 is the only element which appeared more than 2. So 2 appeared exactly 2. Okay. So first we are going to, for every element, okay, so when we say two loops like the outer loop and inner loop, so for every element in the outer loop, we are going to iterate through the every element in the inner loop, and then we are going to calculate how many times this outer loop element occurred in the inner loop, and then we are going to uh, do count. Like let's assume in the inner loop you have this count place like where nums of I equal to nums of j. If this is the case, you increment the count, right? So after completing the inner loop, you check if count is greater than n by 3. Yes. If in that case, like you just make the nums of I as your result. Okay. So if we observe this, look, it's big of n square time complexity. Okay, and big of one space complexity. This looks not so optimal solution, right? So we need to find another way. So interviewer might not be happy with this solution. So now that's where the second solution using hash map. Okay, hash map. So as we know, like whenever we want to know something like counting the frequencies, okay, of any element, a hash map is one of the good approach, right? So good data structure basically. So if we take this into the consideration, so first we are going to iterate through this array. Okay, we are going to count and store the occurrences. Let's assume 1 comma 4, the key value pairs. Okay, 3 comma 1, 3 occurred one time. Okay, then 2 comma 2, that means 2 occur two times. Then we are iterate through this one, okay, hash map, and we focus on the focus on the keys whose value is greater than n by 3. Okay, here we know n by 3, 7 divided by 3 equals to 2. So this one will be part of our result. 3 cannot be, 2 cannot be. So at the end we are going to return only 1. So with this, the time complexity is going to be initially big of n for this loop, and let's assume if the all elements are unique. Okay, so you are going to iterate through this hash map again big of n, so that is nothing but big of 2n. So if you remove constant, and then it's going to be big of n time complexity. But the space complexity is also going to be big of n because you are going to store all the elements in this hash map. So which is not ideally good, right? So now with this approach, there is a disadvantage with the space complexity. Okay, but what we can do is we'll quickly submit one of my code, okay, which I just submitted few minutes back, okay, with this approach, and we'll see how it works. So initially I took this n equal nums dot length and a map, and I iterating through the nums, and then I'm filling the map, and I'm having this result set. So then I'm iterating through this. So basically, like you no need to iterate through these nums. Okay, you can directly iterate through maps.keyset and focus on that. But just I took this. Okay, now let's give a run. Uh, it got accepted, and just give a submit. So it took 8 milliseconds and it got accepted. So here one more thing I would like to, so you no need to call this map.remove, or else you no need to iterate through this. Okay, rather you can iterate through your hash map. Okay, and you can focus on a value who is like greater than n by 3. That you can do at this stage. Okay, so okay, now this approach is worked and it's good, but here we seen the disadvantage with the space complexity. Now this is where the third approach, so that I feel a good approach, that is Boyer-More OAT algorithm. OAT algorithm. So here you need to keep in mind is, so let's assume when n is 8, okay, k is 3, at most how many elements can be major? At most how many elements? Can we say k minus 1, right? So let's take an example. So 1, 1, 1, 1, 3, 2, 2, 2, okay, where n is size of 8 and k is 3. So 8 divided by 3, that is nothing but 2, okay. So if we carefully observe, so there are only high chances like two elements can be major out of these eight elements, right? So here in this example, you can see only one. So at most two, that means it can be zero and one also. Okay. So let's assume another input. So one, 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 and then three, 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 three. Okay. So here the major elements are one and three. So two. So is there any way where it can be greater than k minus 1? No, right? So there cannot be three major elements in this array when the size is of 8, right? So this is one thing you have to keep in mind. So this indicates, okay, when k is 3, so you have to focus on only two elements. So when I say elements, so let's assume candidate 1 and candidate 2, right? Because only at most two elements can be our answer. It can be 0, it can be 1, it can be 2. Okay. So when there is, sorry, for n divided by k, at most k minus 1 major elements are going to be in that array. So this is one thing you have to keep in mind when you are going to learn about this algorithm. Okay. Now let's dry run our input and see how it works. So 1, 1, 1, 1. Okay. 3, 2, 2. I take this 7 example. So n equal to 7, k equal to 3, 7 divided by 3, that is nothing but 2. So at most, two major elements can come out of what I can say, this particular sorry, this particular input. Okay. Now let's see. So voice more algorithm works on two candidates here, right? So I am taking candidate 1, can 1 and can 2, and I'm going to count their occurrences also. For that I'm taking count 1, count 2. Okay. Initially all are going to be 0 initially. So what I'm going to do here is, whenever I'm going to start, okay, initially I check whether this is equal to candidate 1. No. I check, is this equal to candidate 2? No. So first initially it is not equal to candidate 1 and candidate 1 is 0. That means there is no potential candidate who can come and become a major, right? So I make, or else I turn this candidate 1 to point this one, this element, and I make its count incremented by 1. Cool. Now we'll go through the second element. So we'll see, is is this element equal to candidate 1? Yes. Then I increment its, what I can say, counter. Then I come here. Is it same? Yes. I increment its counter. Then I come here. Is it equal to candidate 1? Yes. I'm coming to here. So why I'm not checking with candidate 1? Because if it is equal to candidate 1, then there is no mean to check for candidate 2. Okay. Now we'll come to this one. Is it equal to candidate 1? No. That's where we'll check for candidate 2. Is it equal to candidate 2? No, because candidate 2 is 0. Now, is candidate 1 is 0? No. Is candidate 2 is 0? Yes. That means there is no potential element which can be a major for candidate 2, right? So we never know, like next upcoming three elements can also, sorry, next upcoming two elements can also be 3, right? So then I make this candidate 2.3 and I increment this by 1. Okay, it's count. Now at this stage, candidate 1 is 1, candidate 2 is 3, count of candidate 1 is 4, count of candidate 1 is 1. Cool. Now we'll come to this level. Okay. Is this equal to candidate 1? No. Is this equal to? No. Is count 0? Count no? No. Is if this element, okay, if this element is not equal to this and not equal to this, okay, then that means this is a different element now, right? This means a different element. So now you are encountered to three different elements in your array. So that is not going to be true, right? So at the end of the day, your output is going to be two elements, one or two. When I say like num1 and num2, okay, so it cannot be part of your what I can say, it's not a correct approach. Then what we do is, if the current number is not equal to candidate one, candidate two, that means it's a different. Then I decrement my count by one, okay, and I decrement my count to two by one. That means it's zero. The reason why I'm decrementing here, because I can make a room for the next candidate. Okay, I will show you that. So now it's about this one. So is equal to candidate 1? No. Is equal to candidate 2? No. Is count 1 0? No. Is count 2 0? Yes. That means now this can be a potential candidate now. Okay. That means now this can be a potential candidate. So count to 2. Sorry, candidate points to the 2 and count is going to be 1. So now we're done with iterating through our input array. Now at the end, if you see, our candidate is pointing to 1, candidate 2 pointing to 2. So with this one pass, okay, one pass, now we found two elements who can be what I can say, who can be a major elements in the array. Right? So now what we are going to do here is we are going to iterate through the second pass, second loop. So where what we are going to do here is we are going to check this one. If one equal to one, okay, after this one first loop, okay, we'll set count equal to zero, count equal to one. So initially we use this count one, count two just to eliminate the different elements. That's the only purpose of count one and count two in the first pass. So after first pass done, we initialize them to 0 and 0 again. So now we'll start again second loop. 1. Is 1 equal to candidate 1? Yes. Now increment count 1. Is 1 equal to candidate 1? Yes. 1, yes. 1, yes. Now 3. Is 3 equal to candidate 1? No. Is 3 equal to candidate 2? No. Now let's 2. Is 2 equal to candidate 1? No. Is 2 equal to candidate 2? Yes. Now candidate 2 count is 1. Is 2 equal to candidate 1? No. Candidate 2, yes. 2. So now you got the occurrences of these two major elements, that is nothing but 4 and 2. Okay. Now you need to check whether this number is greater than n by 3. If it is greater than n by 3, then make this as a part of result. If this is greater than n by 3, then this is a part of your input, your output. So since in this case only 4 is greater than n by 3, then only 4 is going to be your output. Sorry, 1 is going to be your output. Okay, so that's all it's about this algorithm. So time and space complexity. So it's going to be big of n for initial, then again big of n for another loop. So it's going to be big of n. So actual big of 2n. So if we ignore the constant, then it's going to be big of n. So why we are ignoring? So I request you to learn about how space and time complexities will be calculated. So space complexity. So space complexity is going to be big of 1 because we are not taking any other, what I can say, uh, extra space apart from the constants. So that's all for this particular algorithm. Now we'll quickly go through and see one of my other submitted code. So here it is. I'm just taking this here so that I can quickly explain you. So now if you carefully observe here, so candidate 1, candidate 2, count 1, count 2. So I'm iterating through the array for the first loop. So where you can see if it is equal to candidate 1 equal to num1, then incrementing count 1. Else if count 2. If candidate 1, sorry, count 1 0, that means there are no candidates at this point of time. So I'm making the current number as candidate 1 and incrementing the count 1. If count to 2 is 0, that means there is no potential candidate which can be a major. So then I'm making candidate 2 equal num and then candidate 2 incremented. So if I found any different element apart from candidate 1, candidate 2, where count is not 0, count 1 not 0, count 2 not 0, after filling all this, okay, the final step is like I need to decrement the count 1 and count 2 because the number which I got is the unique, okay, different number. So that I explained. So after completing this loop, I can be holding what I can say candidate 1, candidate 2. Okay. Now I set their counts to 0. Now I iterate through these nums of array again. So I check if the current number equal to candidate 1, increment count 1, candidate 2, increment count 2. Okay. Now I got count 1, count 2. Now I go and take the what I can say this one array list because at the end we need to return the list. Okay. So now count one, if count one is greater than num sub divided by, let's take candidate one into the consideration. If count two is greater than then, let's take candidate two equal to 0 and then return result. Let me submit it quickly. So you see here it took 2 milliseconds and it beats 98.52 of online Java submissions. So I think which is far better than our previous approaches where it took 8 milliseconds. Okay. So this is one of the good algorithm when you would like to work on something to find the major element out of an array. So I request you to spend some time on learning about this particular algorithm and I hope you find it helpful. So finally, Hari Bol.